Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the hybridization calculation students. I'm giving the best trick in this section to find hybridization to any molecule you can find easily. Just you have to remember one trick, then you can easily find the hybridization students. Understanding after completed this video students, you will get the clear idea how to find the hybridization students. Understanding, so I'm giving the best trick to calculate the hybridization in this topic. Okay, now best trick. What is the trick? So first I'm giving the trick students, then I'm going to discuss the hybridization. Okay, now what is the trick students to find hybridization? Listen. So total number of valence electrons. Okay, suppose the one molecule given, NH3 molecule given, ammonia, nitrogen valence electrons, 3 hydrogens valence electrons. That means all what are the elements are present in the molecule, all valence electrons you have to take the sum students. Understanding, so that's why I'm taking as total number of valence electrons. If it is equal to 8, if the total number of electrons, total number of valence electrons, if the total number of valence electrons valence electrons equal to 8 or less than 8, clear, equal to 8 or less than 8, then this number, total number of valence electrons should divide with 2. Clear, this is the first trick students, this is the best trick, first one. Now coming to the second trick. What is the second trick? Listen students, what is the second trick? If the total number of valence electrons, if the total number of valence electrons greater than 8, then total number of valence electrons should divide with 8. Only these two tricks you remember students, you can find any molecule, any type of molecule hybridization students very easily. Understanding, just if the total number of valence electrons, if it is equal to 8 or less than 8, the total number of valence electrons should divide with the 2 nana. If the total number of valence electrons value is greater than 8, should divide with 8. Understood? So these two tricks you remember students, and you can find any molecule learner. So first I'm going to discuss the one example, beryllium chloride, BeCl2 molecule. What is the example I'm taking? Beryllium chloride. I'm going to calculate by using these two tricks how to find the hybridization BeCl2 molecule. Now see students, here which elements are there? Beryllium and chlorine kada. So beryllium chlorine total number of valence electrons you find it. So first beryllium atomic number 4, 1s2 2s2 kada. How many valence electrons there? This is the second shell, valence shell, 2 electrons. So total valence electrons 2 are there. Are you clear? 2 valence electrons are there in beryllium atom. Now I am taking the chlorine atomic number 17, 1s2 2s2 2p6 3s2 3p5. It is the third shell, is the valence shell. Total how many valence electrons are there? 7 valence electrons. 2 plus 5, 7 valence electrons. Clear? 7 here, 2 valence electrons, here 7 valence electrons. Understood? But here how many chlorines are attached to beryllium? 2 chlorines are there. So 7 valence electrons into 2, total how many? 14 valence electrons. Are you clear students? You have to multiply with 2. Beryllium only 2 valence electrons. Clear? Beryllium 2 valence electrons. Next here chlorine 14 valence electrons. This 2 add 2 plus 14 how much students? 2 plus 14, 16 valence electrons. Clear? Now 16 valence electrons, it is total number of valence electrons. It is greater than 8 or less than 8 or equal to 8. Second trick, see. If the total number of valence electrons greater than 8, yes, 16 is greater than 8. correct, it is greater than 8. So that's why you have to follow this trick. Second trick you have to follow. Now this total number of valence electrons 16, we should divide with which number, students? 8. So that's why 16 valence electrons you have to take 16 by 8. This 16 valence electrons should divide with 8. 16 by 8, how much? 8 2s are 16. 2 means which hybridization? Sp hybridization. Sp. Just you remember, students, here I am giving the I'm giving sp2. How many valence electrons there? Then what is the hybridization? I will tell you here. 2 means sp nana. 1 s, 1 p, total 2. 3 means sp2. 1 plus 2, 3. 4 means sp3. S1 p3. 1 plus 3, 4. 5 means sp3d. Okay. 6 means sp3d2. 7 means sp3d3. S1 3, 3 plus 1 4, 4 plus 2 6, 1 plus 3 4, 4 plus 3 7. So like this total we have sp3d3 up to sp3d3 hybridization, students. This table you have to practice, it. Now we got here 2 number answer, that's why it is which hybridization? Sp. Clear? Understanding? So next I am taking the one more second example, students. BCl3 molecule I am taking. Second example. Which one? BCl3. Total 5 hybrid. Total how many, students? 6 hybridizations we have. Yes, sp, sp2, sp3, sp3d, sp3d2, sp3d3. Total 6. So I am giving the example, students. BCl3 I am discussing now. BCl3. Now calculate Nana boron atomic number 5, 1s2, 2s2, 2p1. Total how many valence electrons? 3 valence electrons. 2 plus 1. Clear? 2 plus 1 how much? 3 valence electrons. And next coming to the chlorine 17 kada, atomic number 1s2, 2s2, 2p6, 3s2, 3p5. How many valence electrons, students? In 3s2, 3p5, 7 valence electrons. Total 7 valence electron. But here how many chlorines attached? 3 chlorines. So that's why 3 into 7, total 21 valence electrons are there. Now this is 3 valence electrons. This 3, this 21. Total you have to do. 3 plus 21, how much, Nana? 24. Total number of valence electrons 24. Now this number is greater than 8 kada. According to trick number 2, if it is greater than 8, what is the formula? You have to divide with 8. Total number of valence electrons should divide with 8. So that's why by 8 do. 8 3s are 24. 3 answer came. 3 means which hybridization, students? sp2. This is which hybridization? sp2. Over. Now see here, third example, students. sp3 hybridization. One example I am taking CH4. Third example, CH4. CH4. Carbon atomic number 6, 1s2, 2s2, 2p2. Hydrogen 1, 1s1. Total how many valence electrons? 4 valence electrons. Here hydrogen, so 4 are there. Hydrogen 1, 1s1, only 1 valence electron. But 4 there means 4 into 1. How much? 4 valence electrons, correct? 4 valence electrons. So total number of valence electrons? 8 valence electrons. Now see, this is the total number of valence electrons. How many? 8 came. Are you clear? This is the total number of valence electrons. 8 came. Now total number of valence electrons. So if it is equal to 8 or less than 8, the total number of valence electrons number should divide with 2 kada. So that's why total number of it is equal to 8 kada. Equal to 8. So that's why this value we have to divide with 2. Understanding? According to the trick number 1. So 8 by 2 means how much you will get? 4. 4 means what is the hybridization, students? sp3. Clear? So what is the hybridization? sp3. Understood? Now see, students, one more example. sp3d I will discuss you. sp3 completed. Now sp3d PCl5 molecule I am taking. PCl5. Phosphorus atomic number 15 kada. 15 electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3 kada. How many valence electrons? 2 plus 3, 2 plus 3, 5 valence electrons. Chlorine atomic number 17, 1s2, 2s2, 2p6, 3s2, 3p5. How many valence electrons? 2 plus 5, 7 valence electrons. But here 5 chlorines are there, so that's why you have to multiply with 5. 7 5s are 35 valence electrons. Then 5 valence electrons plus 35, total how much, students? This 5, this 35, add here. 5 plus 35 valence electrons, total 40. Total valence electrons how many? Total valence electrons 40 km. It is greater than 8 kada. So that's why you should divide with the 40 number with the 8. How much, students? 8 5s are 40. 8 5s are 40. 5 means which hybridization, students? sp3d hybridization. So this hybridization is which one? sp3d. Clear? Understood, Nana? This one, this is PCl sp3d. Now I'm giving the this example, sp3d2, fifth example. Now see, students, sp3d2, what is the example? You can take sp3d completed, sp3d2, sf6 I'm taking. See here, sf6. sf6. Now tell me, students, sf6 molecule, sulfur valence electrons, sulfur atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. How many valence electrons? Third shell is a valence shell. 2 plus 4, 6 valence electrons. Right. Now 6 fluorines are there. Fluorine atomic number 9, 1s2, 2s2, 2p5. How many valence electrons? 2 plus 5, 7 valence electrons. But here 6 fluorine atoms are there. 6 into 7, 6 into 7 kada. 2 plus 5, 7. 6 atoms are there. 6 into 7, 42 valence electrons. Then 6 plus 42 add. Then you will get the total number of valence electrons. How many? Total number of valence electrons, 42 plus 6, 48 you will get. It is greater than 8. Are you clear? So that's why it is greater than 8. That's why we should divide with 8. Are you clear? This is a trick number 2. It is greater than 8. That's why you should divide with 8. See, 48 by 8 means 6 you will get. Okay, 6 means which hybridization, students? Here I told you 6 means what is a hybridization? sp3d2. Okay, right here sp3d2 completed. Clear? Now see, students, next example, sp3d2 over. Now I am giving the example sp3d3, if7 example I am taking. if7. Now see, iodine. Iodine is which group element, students? Here you don't need to write atomic number, electronic configuration, students. By seeing this element you can easily identify iodine is the halogen element, correct? Iodine, this is interhalogen compound. It is iodine is the halogen. Okay, halogens are having 17 halogen 17th group elements. They have the 7th group na, so that's why they have 7 valence electrons. Understanding? So 7, that first you have, if you don't know the atomic number, just to go through that which group element that is. So just you have to identify, students, then you can easily write the how many valence electrons are there. Are you clear? If suppose the group is 5th A group 5 valence electrons, 6th A group 6 valence electrons, 7th A group 7 valence electrons, 1st A group element 1 valence electron, second A group element 2 valence electrons, third A 3 valence electrons, 8th A group 8 valence electrons. Understanding? So iodine is 7th A group element, total 7 valence electrons will be there. And fluorine also halogen, 7 valence electrons. So but here how many fluorine atoms are there? 7 there. So that's you have to multiply with the 7. 7 sevens are 49 valence electrons. Now this 7O plus 49 you have to add, then you will get the total number of valence electrons. Total how much, students? 56 you will get. This is the total number of valence electrons. 56. It is greater than 8, correct? It is greater than 8. So that's why this 56 we have to multiply with 8. Clear? According to the trick number 2. 56 by 8. How much, students? 7 you will get. 7 means sp3 D3 hybridization, correct? 1 yes, so 1 plus 3 4, 4 plus 3 7. Are you clear? 1 plus 3 4, 4 plus 2 6. Understood, Amma? So like this you have to calculate the hybridization. First you have to find the total number of valence electrons, then you have to calculate, students. Understood, students? Understood, Amma? How to determine? Here I gave you best trick. It is very very important trick, students. If you remember this trick, you can easily answer any type of hybridization. Understanding? You can easily find it, students. Hybridization, just you remember this two tricks. This is a trick number 1, this is a trick number 2. If the total number of valence electrons equal to 8, less than 8. If the total number of valence electrons greater than 8, should divide with 8. Less than 8 or equal to 8, you divide with 2. Over. Then you can find it. And after that, this table you have to remember. 2 means sp3, sp2 4, sp3 5, sp3d. Like this you have to practice it, students. See, students, XeF2 molecule I am taking. Here, how many valence electrons? Calculate. Xenon element is there. Xenon, which group element? It is a noble gas element, 8th A group element. So that's why 8 valence electrons will be there. Correct? 8 valence electrons. Directly I am writing, students. Fluorine, it is a 7th A group element, 7 valence electrons. But here 2 atoms are there. 2 into 7. Are you clear? Understood, Amma? 8 valence electrons, 2 fluorines. Fluorine 7th A group element, 7 valence electrons. 2 atoms are there. 2 into 7. Then how much, Nana? 8 plus 2 sevens are 14. Okay, now 14 plus 8, how much? 22. We got 22. It is greater than 8 kada. So that's why we should divide with 8. According to the trick number 2. It is greater than 8. Should divide with 8. Now exactly correct table is not cancelling. Correct? Here 22 by 8 came. So 8th table, how many times it will get cancelled, students? 2 8s are 16 kada. 2 8s are 2 8s are 16. 2 take number. 16 means how much there left? How much left is how much left, Nana, still? 16 means here 4, here 2. Total how much? 6 left. Clear, students? 6 still 6 is there. Understanding? 8 2s are 16 kadama. 22 kada here there. 16 came. 16 22 minus 16 means here how much difference? 6 there. So that 6 is which one, students? It is less than 8 kada. So that's why should divide with 2, Nana. If it is less than 8, should divide with 2. This is the trick number 1. Here we have to follow the both tricks. This is a trick number 1. This is a trick number 2. Are you clear? So both tricks you have to take. First, how many times 8 2s are? That 2 number you write. Remaining how much there? 6 is there. It is less than 8 kada. Should divide with 2. Then 2 3s are how much, students? 2 3s are 6. 6 3 times it will get cancelled. That 3 number you have to add here. 2 plus 3 5. 5 means which hybridization, students? 5 means sp3 dehybridization. Are you clear? Understanding? Here in this case, that means if it is cancelled, okay. If it is not cancelled, how much remaining? That you have to divide with 2 only. Always should divide with 2 only. How much left? That you should divide with 2 only. That means trick number 1 you have to follow. Then this 2 8 2s are 16 2. I here 2 3s 3. These two values you should add, then you will get the hybridization. And one more example, see, students. Example, XeF4. XeF4. Xenon, how many valence electrons? 8. Fluorine, 7 valence electrons will be there. 7 4s are how much, students? 7 into 4. 8 plus 8, 7 4s are 28. 8 plus 28, students? 36. It is greater than 8. So that's why this is a trick number 2. Then greater than 8 means should divide with 8. Yes, 36 by 8. Now see, students, it is also not cancelling correctly. So here 8 4s are 32 kada. 8 4s are 32. 4 value right here. 32 means here still how much left? 4 is there. That is you should divide with 2 because it is less than 8. Should divide with 2. Then 2 2s are 4. This value and this value both you should add. 4 plus 2 how much, Nana? 6. 6 means which hybridization? sp3d2 hybridization. 1 yes, so p3. 1 plus 3 4. 4 plus 2 6. Are you clear? So here we used which trick, students? Trick number 1. Are you clear? 2 tricks we are using. Are you clear, students? If suppose the table is not cancelled correctly, then both tricks you have to follow, students. And how many times cancel? That write fast. Remaining you should divide with 2. How many times? That add here. Then you will get the total value. Then you write which hybridization. Are you clear? Now one more, see, students, one more example I am discussing. XeF6. Okay, XeF6. Now see here also same. Xenon 8 valence electrons, fluorine 7, 6 atoms are there. 8 plus 6 sevens are 42. 42 plus 8, how much, Nana? 50. It is greater than 8, should divide with 8. This is the trick number 1. Sorry, this is trick number 2. Okay, now 50 by 8 means 6 8s are 48. 6 8s are 48. 6 I am taking. Okay, now how much left here? 58. 6 8s are 48 means here still 2 is left. Divide with 2, it is less than 8. That's it, divide with 2. 2 by 2, 1. So this value and this value should add. Are you clear? These two values you should add. Understanding, Nana? Two values. Then 6 plus 1. 6 plus 1 means which hybridization? sp3d3. S1p3. 1 plus 3 4. 4 plus 3 7. This is sp3d3 hybridization, students. If correctly cancelled, no problem. If not cancelled means this is the way. Are you clear how to find the hybridization, students? Understanding, Nana? So these are the two tricks you have to remember, students. Okay, if the total number of valence electrons equal to 8 or less than 8, should divide with the total number of valence electrons 2. If it is greater than 8, should divide with 8. Are you clear? So this is the trick you have to find the hybridization topic, students. Here exceptional case, if suppose directly cancel, if not directly cancelled also, I discussed you. So any type of molecule you can easily calculate the hybridization, students, by using this trick. Okay, Nama, I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana.